Hi, I'm Troy Ellison with Cloacina, and today we're going to be talking about the Cloacina difference. Whether you're an engineer, a future client, or an end user such as an operator or maintenance technician, or one of our many competitors looking to actually improve your product, we'll have something here for you. In the early 2000s, we were dismayed at what we were having to buy and what people were calling packaged wastewater treatment plants. They were not operator friendly, they were built for the bottom line of the manufacturer, and they were extremely short-sighted in their design and construction techniques. In 2008, we started on a journey to try and build the world's best packaged wastewater treatment plants. First and foremost, we're built in America, specifically Arroyo Grande, California, and we couldn't be more proud of that. Secondly, we're not owned by a giant multinational firm. As such, we're not required by some other division of the giant corporation to integrate equipment that frankly is subpar or doesn't fit the actual application. When you invite Cloacina to join your team, you get all of our industry experience to help make your project and design even better. Another huge difference that you'll be able to see as we walk through the plant is the fact that every single tank that we build is manufactured out of stainless steel. They're available in standard 304 stainless steel, or we can go ahead and upgrade to 316 depending on your particular application. There is no other competitor in the world that builds their plants out of stainless steel as a standard. Another big difference between us and some of our competitors is the fact that we don't push proprietary technologies. Everything you see behind us that's employed in the construction and design of our wastewater treatment plants is tried and true membrane bioreactor technology. We have a nice conservative design approach to every single one of our plants. Another big difference between us and some of our competitors is the fact that we weren't a group of venture capitalists looking to increase shareholders' profits by investing in some water technology. We were a group of operators and maintenance technicians who wanted to build the world's best wastewater treatment plant. While our approach to our products are revolutionary, we do not push radical, unproven designs. We utilize universally agreed upon principles of design in all of our projects. Let's dive into some of the specific details that set us apart from everybody else. Cloacina is revolutionizing the packaged wastewater treatment industry. Clients notice a tangible difference in every phase of the project when they work with Cloacina. We believe in beginning with the end in mind, and every successful packaged wastewater treatment plant project begins at the bidding and proposal phase. Cloacina is contacted by a client or sales representative with needs ranging from the replacement of aging infrastructure to the desire to reclaim treated wastewater. Information about the project is collected, and if necessary, a job walk is conducted. Clients and their project teams are invited to tour our factory as well as other installed Cloacina plants in operation. Cloacina wants to be a member of the client's project team and not just an equipment supplier. Our sales team works alongside the client, their engineer, and contractor to provide treatment options and design input. The sales team is prompt and responsive. We strive to meet deadlines for information and budgetary proposals. Cloacina is an open equipment integrator. We want clients to know exactly what they're buying and how much it will cost. Our budgetary estimates are transparent and project-specific based on the design parameters. Cloacina budgetary estimates include value engineering, all costs to manufacture a complete treatment system, and controls and electrical integration. We don't want clients to spend money on things they don't need. Cloacina projects are successful because we begin with the end in mind, and that's the Cloacina difference when it comes to bidding. Once Cloacina receives an executed contract, our highly skilled group of engineers and designers start immediately on the project. We begin working with your engineering team immediately. We prefer to rope in your operator and maintenance technicians so that we can get a plant that everybody is happy with at the end of the day. Once Cloacina receives an executed contract back from a client, the project enters the design phase. Our design team, which consists of highly skilled engineers and draftsmen, produces detailed project-specific documents that include process flow diagrams, process and instrumentation diagrams, biological modeling if applicable, and structural analysis. During every step of a project, our clients experience the Cloacina difference, or things that set us apart from other manufacturers. Some of the unique aspects of Cloacina's design phase include: our design team members have decades of experience in designing water and wastewater treatment systems. Every Cloacina packaged wastewater treatment plant and piece of equipment is custom designed and engineered for the client's specific discharge permit and waste stream. We do not believe in a cookie-cutter approach to wastewater treatment. The design team can provide clients with calculations showing why each piece of ancillary equipment was selected for their particular system. Our products can be integrated into existing on-site equipment and control systems. We offer expedited design and engineering services on most models. Cloacina can provide clients with equipment lifecycle analysis. Our design team is highly responsive to client questions and concerns throughout this phase. We look forward to showing you what it is like to work with the design team that is revolutionizing the wastewater industry. Now we're going to talk about the Cloacina difference in terms of fabrication and upfitting. We're standing now on top of the Mempak M75K. This particular plant is rated at a 75,000 gallon per day municipal spec influent. and produces Title 22 quality effluent. When you take a look at the tanks that we're standing on, as well as all of the tanks that are in the background, 100% of them are built out of stainless steel. It's the only thing that we build all of our tanks out of. As a result, we avoid any cross-contamination with carbon steel. We are the only manufacturer in the world that builds 100% of all of their tanks out of stainless steel. Every single tank that you see, all of the welds have been electrochemically passivated. Every single one of the tanks is designed by our structural engineer, who's licensed in 48 out of the 50 states. As a result, we're able to maintain complete and total control over our tanks. Additionally, before they leave our tank shop, which is next door, every single one of the tanks is hydrostatically tested and leak tested. As a result, we, and subsequently you, can have complete and total confidence in our tanks on your project. We're going to walk through the treatment plant features as the water flows. We have our headwork screen on top of the anoxic chamber. If your particular project doesn't have biological nutrient removal, then we would just dump right into the aeration chamber. As the influent wastewater enters the system, it actually comes through an inlet pipe that's on the side of the treatment tank, which goes through an influent flow meter. That's where we start the process. That particular influent flow meter is set up with an empty pipe detection, so in the event that your lift station or EQ transfer system has leaky check valves and drains down and gets air into the system, it doesn't record erroneous readings. We then come into a minimum 2 millimeter perforated screen segment for the municipal specs. For industrial, we may go into a wedge wire. Depending on your particular application and your appetite for risk, you may have a simplex or duplex screen. This particular screen is a 2 millimeter perforated screen segment with washing and compaction zone, which dumps down a chute to the side and goes into a trash can or dumpster, making it so that you as the operator don't have to carry wet bags of screenings or solids down the ladder and into the dumpster. One of the other things that you'll notice is the fact that there aren't auxiliary control panels here. That's one of the nice features that we provide, is the fact that every single piece of equipment we supply goes back into our MCC. As a result, you don't have a bunch of auxiliary control panels that you then have to figure out the components of those in addition to ours. That's one more way that we wrap everything together under our umbrella. As a result, you have the solenoids that are independently controllable from the MCC themselves. So you may choose to increase or decrease the specific washing and compaction zones. And now we've entered the biological nutrient removal process. This is our anoxic zone. Your particular application, tuned for your specific site needs, may have multiple anoxic zones. This particular project just required a single anoxic zone to meet its biological needs. You have the anoxic mixer here, which I've got raised up, and it's on a stainless steel slide rail so that it gets into the exact place it's supposed to be every single time. It's on a stainless steel cable that's attached to our davit arm crane/winch, which again comes with the system. It's designed specifically for it so that your operator or maintenance technician can raise and lower the mixer in minutes, allowing for quick and easy inspection of components. If it's not easy to do, they're not going to do it. We're going to keep walking down the wastewater treatment plant and show you a couple more features. We have an ORP probe in the anoxic tank, as well as a level transducer that are both on the Cloacina patented slide rails, which we'll talk about more later. With that, they come with a probe wash system so that you as the operator can extend out the actual requirements to physically touch and deal with the ORP probe or other pieces of sensory equipment. The next feature of the anoxic zones is the fact that at max water surface elevation, we have an overflow built into the tank. This allows you to run the outlet of this overflow out to either an EQ basin, an overflow basin, or a lift station or equalization tank, allowing for the water to go there rather than spill over the top of the tanks in the event of an equipment failure. Next up, we flow through the anoxic zone and through a weir into the aerobic zone. The tanks to my right and to my left are both aerobic zones, and they're designed to run in series. The first feature that I wanted to talk about are the actual aeration diffusers. We utilize fine bubble diffusers. They're specifically made out of a product called polysiloxane. This is a huge upgrade over the traditional EPDM, where you're having to change those out every several years. We have independently adjustable aeration headers that go into each of our aeration tanks. We have isolation valves that allow you to fine-tune specifically where you want to send the most preferential amount of air to. The next features that I wanted to talk about in the aerobic zone specifically have to do with some of the sensory equipment. Cloacina provides a ton of sensory equipment so that you as an operator can have complete and total oversight and control over the actual treatment system, and do so even remotely. In front of me, you'll notice two slide rails. that have three pieces of sensory equipment. The first one is the level transducer, which is set to the bottom of the tank. The second one is the mixed liquor suspended solids probe, which allows us to run a program so that we can automatically tune and adjust the wasting based off of the actual mixed liquor suspended solids in the aerobic zone. The next one is the dissolved oxygen sensor. This allows us to actually fine-tune the aerobic set points to your specific project needs. The Cloacina slide rail system is something that we developed decades ago, and it allows for all of our sensory equipment to be mounted onto these so that you can easily raise up and lower down the individual pieces of sensory equipment into their specific strata that we designed them to be in the actual tanks. As a result, it reduces damage to the equipment. It allows us to put things in the specific location that we want to every single time. Additionally, it also avoids damage to the equipment by fixing it to a specific location rather than allowing the pieces of equipment to jostle around against the wall in aerobic conditions especially. The last feature of the Cloacina slide rail system and all of our sensory equipment that needs to be cleaned is the fact that we have a master probe wash system that runs throughout all of the treatment plant and goes to all of the individual pieces of equipment and supplies potable or reclaimed water to the probe head and periodically injects or bursts water across the face of it, thus cleaning the piece of equipment and extending out the actual maintenance interval for somebody to touch that piece of equipment. There are junction boxes near all of the pieces of sensory equipment, so in the event that you have a failure of an actual probe itself, you can come back to a junction box that's usually feet away from the actual slide rail system, disconnect there, pull your piece of equipment, install the new piece of equipment, and then make determinations right then and there. You don't have to pull wire all the way back to the MCC. Next, we're going to talk about the forward activated sludge pumping system that's on the skids. We're going to talk about some of the details as it specifically pertains to pumps, piping, and valves. Here you have what's called forward activated sludge pumps. You'll have to forgive some of the mess here. This particular plant isn't finished. It's about 90–95% done. And you'll notice things that are temporary that'll get replaced with permanent electrically etched tags at the point in which we finish up the project. Specifically, I wanted to talk about some of the features that are there for the operator and maintenance technicians. One of the first things you'll notice is there are gauges on the suction and discharge side of the pumps. This is to allow us to confirm where the pump is on its curve before it ever leaves, as well as this is an excellent troubleshooting tool for the operator or maintenance technician in the future to figure out if things are clogging, maybe the impeller's worn down, or you've got something going on where you're not actually getting the intended flow. Every single one of our pumps is installed so that it can actually be removed when you need to get to it. You'll notice they're sitting on pump stands, they're bolted down, they're easy to get to, and they all have flanges on the discharge and suction side. This allows for a maintenance technician, if they needed to swap this pump out, to do so in just a matter of an hour or so, versus trying to climb through equipment and get to things where they are difficult to reach. You'll notice there's a raceway of conduits going underneath me. Our fabricators knew that somebody wouldn't want to have to be able to stand on those conduits and actually built us a raised platform so that it was operator and maintenance friendly. These are the kinds of things that set Cloacina apart. Next, we're going to talk about some of the subtle differences between the way that we install and plumb all of our equipment. You'll notice that there are municipal spec check valves with swing arms. This is a fantastic feature for the operator and maintenance technicians. Additionally, you'll also notice every single piece of hardware that we install is all stainless steel. That makes a huge difference for the lifespan of the equipment and makes it so that you can actually get a piece of hardware off in the future. Next up, we've got little differences such as things like plug valves. Another thing you'll notice as you just look around, take a look at all of the pipe supports and stanchions and hangers. Every single thing is fabricated from stainless steel. You're not going to have to worry about going in 10 years from now, sandblasting and recoating, or having things start to rust out from underneath you. This will last longer than any of us. Next thing I wanted to talk about was the way that we run all of our blowers and blower lines. So again, you'll notice everything is on a nice, neat, tidy stainless steel enclosure or support stand. We also manufacture these in sound attenuated packages. This particular client opted not to go with that. All of our suction and discharge piping is all done out of 304 stainless steel, and it's welded in the exact same manner as sanitary fittings are for food and beverage applications. As a result, this will last forever. We've actually got suction and discharge transducers as well as manual readouts. What this does is it actually goes back to the control system and tells us if we're having an issue with the blower. Perhaps somebody hasn't cleaned the air filter, maybe something's actually in the blower itself, or perhaps one of the fittings has come loose for whatever reason on the discharge side. All of these things can be troubleshot as a result of having the alarm condition that pops up. We have isolator nipples in between the suction and discharge tubing and the actual blower. This is again a small detail but an important one, and it allows us to avoid the implications of electrolysis that would occur with having dissimilar metals contacting the blower. Again, that makes this blower last that much longer. The next little detail is again something that's typically overlooked, but you actually have rubber isolation washers underneath this blower. This allows us to, again, isolate it from the stainless steel that we place it on, as well as reduce any frequencies or damage to the blower as a result of being rigidly mounted. As you can see, the attention to detail is extremely high, and we take into consideration even the smallest of detail into all of our design and implementation. As a result of all of these details and many more, there is no other manufacturer out there that takes into consideration the needs for the operator and maintenance technician. Because the membranes are the heart of a membrane bioreactor, we take extreme care for all of our design in terms of the membrane permeate system. I wanted to talk about some of the features and the differences between us and what you may be accustomed to. We use rotary lobe pumps for every single one of our permeate applications. We do this for a couple of reasons. Let's talk about those. The first one is that you get the absolute best TMP readings as a result of having a PD pump, which provides both the forward or permeate withdrawal in the event that your particular membrane actually does have a back pulse. In conjunction with the fact that we only have a single PD pump, you'll notice that we also have a single TMP sensor. This reads in both vacuum and pressure and is integral to knowing exactly how the system is running. We have all of our chemical injection points here completely pre-plumbed and ready to go. This allows for a completely automated clean in place. There are many manufacturers who don't provide this and simply push that responsibility off to the operator or maintenance technician, whether that's a weekly, monthly, quarterly, or annual basis. The next thing I wanted to talk about is the fact that we are actually an integrator and not a manufacturer of the membranes themselves. As a result, we're an open source integrator. We can utilize any membrane. We have several custom designs that are curtailed to the specific style or type of membrane that you desire. I want to talk about some of the features that we design into all of our treatment systems to make it so that you cannot harm the membranes and it protects you as the operator and maintenance technician from ever damaging the membranes themselves. Let's talk about some of those features. The first is the fact that all of these permeate pumps are on a VFD with very strict ramp up and ramp down guidelines. And then the PLC itself reads in milliseconds and allows instantaneous stops in the event that it ever sees a spike in the TMP, whether that's on the positive or negative side. Additionally, we have a complete mechanical redundancy so that in the event that your particular membrane application requires a back pulse, we actually have what's called blow-off valves or pressure relief valves. And what this does is they're set to just below the factory maximum TMP pressure, and it blows off the pressure and the full flow through these valves, which this particular application is brass Kunkel valves, and it blows them off, making it so that you have zero capability to overpressurize your membranes. The next feature that we provide for all of our municipal spec systems is a mass airflow sensor. So you'll notice on the actual discharge for the membrane air scour blower, you'll notice that there are sensors which read the actual CFM that goes out to the membranes. This allows us to trend it and make sure that the VFD is actually corresponding with the correct flows for that particular permeate range. This also allows us to provide data back to the membrane manufacturer in the event that anything were ever to occur. The next feature that we provide is the ability to withdraw air from the permeate system. Air tends to come out of solution when you apply a vacuum to it. As a result, it tends to gather at the top of the permeate headers, and you can see that these pumps actually run up to the very top of the headers themselves and are able to eject air. We can do this either automatically based off an actual TMP value, or we can set it to run periodically in between a certain amount of user-defined permeate cycles. We build the absolute most robust membrane permeate system. Because of these features, you and your operations team are able to operate the membrane system both effectively without the worry or concern of causing damage to your membrane system. Now that we've covered the forward activated sludge process, let's talk about where that goes. In front of where I'm standing are the actual membrane chambers themselves. On the opposite side of this tank wall is where the actual entrance for the forward activated sludge comes. We install it so that it actually comes under all of the membranes so that you get an upflow or an updraft of the actual FAS so that you get the motive force associated with the 4 to 6Q that we provide for all of our membrane systems. As a result, we have a lower propensity to actually sludge the membranes. This particular side of the manifold is actually capped off, and you'll notice we have an open pipe that goes into the membrane chamber. This allows us to actually run the membrane permeate system without being hooked up to the membranes so that we can test 100% of the program before we ever turn the membranes online. Once it's been thoroughly vetted and it's gone through its QC and QA process and signed off, we then remove these spools and tie in the actual membranes itself. One of the things you'll notice is the fact that we provide some clear piping. This allows you to see in the event that you have a membrane failure or perhaps you've got a ton of air coming into the system, and you can isolate specifically where it's coming from and know which one it's coming from. We have extremely small membrane chambers in comparison to the actual membrane itself. One of the reasons we do this is it preferentially sends all of the FAS up through the membranes itself, which helps to reduce the actual sludging of the membranes. The second thing is, though, this also reduces the amount of clean water that's necessary for a recovery clean for the 1 or 2 times a year that you actually need that. It's extremely easy to drop that small, limited amount of volume down so that you can do periodic inspections of the membranes. You'll notice that some of our competitors place their membranes into the actual aeration tanks, requiring you as the operator to drain thousands or tens of thousands of gallons to actually get to the membrane itself. Or they tell you that you need to go ahead and get a crane out and deal with the implications of that. That's an extremely costly venture. As we move forward through the membrane system, you'll notice that we actually have weirs that determine the actual water surface elevation in the membranes. And the nice thing about this is that we maintain a height that's relative to this weir as it overflows into the RAS collection chamber. And then the RAS returns back to the biological nutrient removal process or just the aerobic process. We then flow into the clear well. The clear well is specifically designed to minimize retention time, but allows just enough water to do CIPs for 1 or 2 of the membranes, depending on your specific application. Additionally, you'll notice that it's covered and allows for complete and total sealing from the actual mixed liquor that shares a wall with it. Let's talk about some of the features of the Cloacina MCC. The first thing you'll notice is that everything is readily accessible and available at the front of the panel. All of our municipal systems come standard with a stainless steel enclosure. Additionally, they all come standard with an actual cooling system or air conditioner that's found on the side of it, also in stainless steel. The next thing is the fact that you have a 17-inch HMI and an analyzer for all of the sensory equipment to come into. Many of our competitors mount this or the HMI on the outside, making it both difficult to see and allowing for rapid decay of the actual piece of equipment. Next up, you have the VFDs. You'll notice there are many VFDs inside of this panel, and with normal configurations, the VFDs are only accessible on the back side of the inner door. One of the things that we started to do years ago was provide remote interfaces for all of the VFDs on the inside of the inner door, so that in the event that you have a VFD failure or even a momentary blip, it allows you to go in and immediately reset. You can just simply go in here, configure or toggle through all of the screens, immediately reset it, and you don't have to have an electrician go in behind the inner door. You have all of your HOA switches out on the front, but it also allows you to close the doors and lock them, and all of them come with keys so that you can limit the access to whoever has that set of keys. These are just some of the standard features that we provide as part of the Cloacina MCC. Right now, we've started the factory acceptance testing process, which is we start all of the pre-checks on all of the pieces of equipment. So we test all of the things electrically, we test all of the things programmatically, and then we move right into an actual hydraulic test of all of the equipment. And we run all of our systems in a loop mode. And then we're able to test them through their diurnal capabilities. We run all of the plants either for days or weeks, depending on how we're tuning things. And it allows us to go from average day flow all the way up to the simulated peak hour flow event. This is a huge difference between us and everybody else because we're not shipping you a system that hasn't been fully vetted and tested. We're shipping you a system that has been hydroelectrically, mechanically tested to the fullest capabilities that we have. So it gives you, as the end user and the engineer, the confidence that the Cloacina system will work the day it is shipped. Once it arrives on site, we reassemble everything, we fill it back up with clean water, and from there, we're able to move quickly into the actual seed sludge process. Because of the extensive factory acceptance testing that we do right here in our shop, it allows you as the client or end user to have the greatest degree of confidence in Cloacina, knowing that this particular plant will show up at your site ready to move water. We hope that you join the Cloacina family and find out for yourselves the true difference between us and everybody else.